This video is on proving that triangles are similar. Our first example is we have angle G is congruent to angle K and angle I is congruent to angle L. Those are already marked in our picture. So our statements, the first statement is our first given. So the reason why these are congruent is because it is given to us. So we would say given. The second statement must be that angle I is congruent to angle L. Angle I is congruent to angle L because it's given to us. Now, since we're proving that the triangles are similar to each other, we use either side similarity, side angle similarity, or angle angle similarity. Because there are no fractions and we have no side lengths, this has to be angle angle. So we have two angles marked congruent. These are similar because of angle angle similarity. On example 5, we have that segment MN and segment PQ are proportional to the lengths of NO and QR. We also have that angle N is congruent to angle Q. So the first statement is that MN over PQ is equal to NO over QR. This is because it was given to us. That was that first part. Our second statement is angle N is congruent to angle Q because it was given to us and it is marked in our picture. On here we have two fractions. That would mean that we would have two sides and one angle. So these two fractions are, if we make sure that it does match along with MN and PQ, and then NO and QR, that these two sides both touch that same angle, so we would have side angle side similarity. Side angle side similarity. Two fractions means you should have two sides. On this next one, we have we actually have three fractions. So that automatically tells us, since we have, so ST would go along with WV, TU goes along with VX, and US goes along with XW. These three fractions tells us that we should have side similarity, and we have side similarity. So on our first statement, we're going to write those fractions. ST over WV is equal, not congruent, equal to TU over VX, which is equal to US over XW. Please understand that these are not segments themselves, these are lengths. That's why there are no segment symbols on them. They're just lengths. So they are proportional, so that's given to us. Therefore, the triangle STU is similar to triangle WVX. Comes straight from our proof. We want to prove they're similar, so we have side similarity because we have the fractions, all three fractions. On 7, we have 1, 2, 3 fractions as well. That means we should have side similarity. We have side similarity here. So our first statement is just our given. So we have length AB over DE is equal to length BC over EF, which is equal to length AC over DF, and that was given to us. We have side similarity. On this next example, we have parallel. Whenever we have parallel, we look for alternate interior or corresponding angles. So we look for the Z or for the F. So Z or F. So if we look at our proof, it says we have, this is a step proof. So the first step is we have that segment GK is parallel to segment HJ because it's given. We need to find corresponding angles, but we already have on statement 2 and 3. On statement 3, we have an angle marked congruent. So let's go ahead and fill that one in first. So we have angle G is congruent to angle J to H to I. So these are marked congruent. So these both touch a different parallel line. This is from the letter F. This is the corresponding angles. So these are congruent because of corresponding angles as well. This is one of the reasons why you have to look at your steps to make sure you don't reiterate the same angle already. So the other corresponding angles would have to come from here, from this part of the F. So to name these, this angle down here, because it only has two lines coming to it, this would be angle K. It's congruent to angle, then we'd have IJH. IJH. We want J in the middle. So IJH or HJI. It doesn't really matter if you say HJI or IJH. And these are because of corresponding angles. So now there are no fractions, there are no side lengths, so that means we have the angle-angle similarity. On this next one, we again have parallel lines. So we're looking for either the Z or the F. So in our first statement, we write out the given. So MQ, segment MQ is parallel to segment OP, not congruent, parallel. So we're looking for Z and F. Now on here, if we look at our step proof, we have, let's look at this first one, angle QMN. So QMN, right here, is congruent to angle OPN. OPN. So how are those congruent? This angle here touches a parallel line. This angle here touches a parallel line. So it's going to be regards to the parallel part. So we also need to find the transversal. This is from the Z. So these two angles are congruent because of the Z, which is alternate interior angles. These are alternate interior angles. Alternate interior angles. But then it says that we have vertical angles. We could have used the other alternate interior angles, but it specifically says vertical angles. We need to find those vertical angles. Vertical angles are inside of here. So we just need to name these correctly. So on this triangle, if I start with Q, which has no arc on it, QNM, angle QNM is congruent to angle. So Q has none, O has none. Angle ONP because of vertical angles. There are no fractions and no side lengths given to us, so these are similar because of angle-angle similarity.